Hello everyone. Today's experiment is oil and water don't get along. Have you ever heard the saying, oil and water don't mix? For this easy science experiment, we observe exactly what does happen when we mix oil and water. Then we'll add another item to the mix to see how it changes. With only a few common kitchen items, like dish soap, we can explore density and the reaction of adding an emulsifier to the experiment. So what do you need? You need a glass jar with a lid. I'm going to be using a test tube for this experiment. A pipe canning jar works great. A cup of water, food coloring, a cup of oil, any type of cooking oil would work, and 2 teaspoons of dish soap. Start by filling the jar with 1 cup of water. Add a few drops of food coloring to the water and then stir until it's combined. Make some observations about the water. What happened when the food coloring was added? Was it easy to mix the food coloring into the water? And does the food coloring stay mixed with the water? What do you think will happen when we pour oil into the test tube? Write down your hypothesis and then follow the next steps. Next, pour 1 cup of oil into the jar. To the oil and the water now that the dish soap has been added to the mix. Write down your findings. Did the oil and the water stay mixed together this time? Do you know why adding the dish soap prevents the oil and water from separating? Science behind the scenes. The first thing that you'll observe is that oil and water will not stay mixed together no matter how hard you shook the jar. Instead, the oil slowly rises to the top of the water. This is because of the density of the 2 liquids. Density is a measure of the mass per unit volume of a substance. Water has a density of 1 gram per milliliter, or grams per centimeter cubed. Objects will float in water if their density is less than 1 gram per milliliter. Objects will sink in water if their density is greater than 1 gram per milliliter. The oil is less dense than the water. This is because the molecules of oil are larger than the molecules of water, so oil particles take up more space per unit area. As a result, the oil rises to the top of the water. The second thing you'll observe is that adding dish soap to the mixture changed the results of the experiment. When oil, water, and dish soap are mixed together, the oil and water don't separate like they did when they were the only 2 items in the jar. This is because of the chemistry of the oil, water, and soap molecules. Oil and other fats are made up of nonpolar molecules, meaning they cannot dissolve in water. Meanwhile, water is made of polar molecules that can dissolve other polar molecules. Soap, like this, is made of molecules that have a hydrophilic or water-loving and a hydrophobic and water-fearing end. Without soap, water and oil cannot interact because they are unlike molecules. When you add soap to the mixture, the hydrophobic end of the soap molecule breaks up the nonpolar oil molecules, and the hydrophobic end of the soap molecule links up with the polar water molecules. Now that the soap is connecting the fat and water, the nonpolar fat molecules can be carried by the polar water molecules. Now the oil and water can be mixed together and stay mixed together. I hope you all enjoyed this experiment, and I'll see you all in the next experiment. Thank you so much.